So hi all, my name is James. I'm currently leading developer experience at 12 Labs, and the title of this talk is Next Generation Video Understanding. So when you think about the topic of video understanding, you probably think about some of the traditional specific computer vision tasks like pedestrian detection, facial recognition, typo estimation, emotion recognition, object detection, and even like instant segmentation, for instance, right? Um, so this slide shows how video understanding has evolved over the past decade. So video was first invented back in 1878, and back then, in order to consume, the content of the video, you have to manually watch through the entire thing. And then when the first speech-to-text model was commercialized in the late 90s, now people was able to extract transcript from the video. But the issue here is that these transcripts are awful to read, and they are often totally disconnected from the visual information. Right? Then, since convolutional neural networks become popular over the past, let's say, 10 years or so, a lot of the computation models was built to tackle different video understanding tasks, just like in the previous slide I shown. But they really focus on a specific task, right? And the output from this model are the tasks or the metadata that basically explaining, different concepts inside the video. The issue here is that these tasks often do not capture the whole meaning or context in the video, and they can create huge discrepancy. So I could argue that the evolution of video understanding is following a pretty similar trajectory to that of language and image understanding. So you see a lot of phenomenal like progress with large language model and large vision model over the past 2 years. And the same thing is happening with the rise of video prediction model, and they can power different use cases that leverage multimodal video embeddings, right? And these video embeddings can be very beneficial for a variety of different downstream tasks, which can be wrapped up as APIs. And these APIs can enable different video-centric application on a variety of use cases. And on the top is like the individual users and enterprise who's gonna interact with the application layer, right, to benefit a lot from the intelligent video understanding. So I want to dive a bit deeper into this concept of video embeddings. So video embeddings refer to the numerical representation of videos in a low-dimensional vector space, where each video is represented as numerical vectors. And these embeddings can capture some of the semantic meaning and visual features of the video. The popularities of video embeddings can be attributed to the multimodal evolution of vector embeddings. So traditionally, vector embeddings will solely focus on, either text or image or audio data. However, with the rise of multimedia content and the versatility of the transformer architecture, there's been, a big shift towards developing embeddings that can, capture all the visual, text, and audio information in a shared space. So yeah, these multimodal video embeddings can enable a wide range of downstream tasks in different domains. And I want to dive really deep into this concept of video search. So video search is the task of analyzing the semantic information of video and thereby enabling efficient and accurate retrieval of specific video content. And this plays a very crucial role in helping users navigate through vast video libraries and discover the videos they're looking for without having to watch them, right? So at Telabs, we have been building a search API that moved beyond the limitation of relying solely on individual data types like keywords, metadata, or transcription, by simultaneously integrating all different forms of information from images to sound to spoken words and on-screen text. Our API can capture different complex relationships among these elements for more human-like interpretation. And it's also designed to detect finer details frequently overlooked by some of the unimodal methods. And additionally, it also supports natural language query, making interactions as intuitive as your daily conversation. So that is on video embeddings and how it enables video search. I also want to quickly touch on this idea of video language modeling. So this is like a sub-research direction between a very exciting research agenda that I've seen last year called multimodal large language model. So in short, video language modeling aims to focus on understanding and generating text-based summaries, description, or response to video content. And this type of research is essential for holistic video understanding because it aims to bridge the gap between visual and text understanding. So as you've seen here on the slide, this is a diagram of a model called Pegasus-1, which is Twelve Labs video language model that we released last October. And essentially take into the video as input, go through sort of architecture with different encoder model, element model, and decoder model, and it generates text output. Out of that is conditioned on the video content. So so video language model can be used to generate description for video, improving searchability. It can also be used for video summarization, where the models generate concise summaries of the video content, and finally it can enhance different interactive meta experience and generating human-like conversation about videos. So we also offer a new video to text API that can accomplish some of the tasks that I just mentioned. So this API leveraged the Pegasus model in the previous slide to analyze the whole context of the video and can generate content based on it. And we offer 3 separate endpoints based on this video to text suite. So the GIST API can produce concise text output like titles, topics, and hashtag. The summary API is designed to generate video summaries, chapters, and highlights. And for more customized output, there's an experimental general API that allows users to prompt specific formats and style, everything ranging from like reports to bullet points to even creative lyrics based on the content of the video. So to illustrate that, I want to show the audience a demo of our API and how that look like, right? So this is the playground of the Twelve Labs platform, and I talk about the search and generate, but we also have a classify API that essentially allows you to be your own video classifier in a zero-shot manner. So I just go to the search API real quick, and we have a couple of index that is already being pre-uploaded for every user account. So for this demo, I'm going to choose the advertising index. So you can see here there's 33 videos in this index, about 54 minutes in total, and this is basically like famous commercial in the Super Bowl over the few years, right? So we offer 3 separate search options: visual, conversation, and text and video. So for the first visual search, I'm going to choose visual, and I'm typing this query: a man drinks Coca-Cola, right? So as you see, it quickly go through all the video in this index and retrieve the video clips that match the search query. So here, this is so that is a man drinks Coca-Cola. Now let's try conversation search. So this is basically semantic search in the transcript, the dialogue happening in the video. So I want to type this query, throw like a girl. And it returns a couple of output here.
Show me what it looks like to run like a girl.
Show the dialogue happening in this clip.
Throw like a girl. Fight like a girl. Show me.
Yeah, so for any video that have heavy content conversation, this is a very useful way to capture that exact segment. And finally, we also offer text in video, which is essentially OCR, right? So let's say I'm trying to type the word Paris. Yeah, so it's gonna. Yeah, so it can capture that word Paris on the screen and return that clip for you. Yep. So that is the search API, and I want to also quickly show you the generate API that I mentioned. So here's generate, and I'm going to choose the same index, the ads index. So generate right now can only work with a single video file. So I'm just going to choose one video and perform the generate course for you to see. So this is like a famous Heineken commercial where I think in the Super Bowl, probably 10 years ago. You can see here I click on all three options: summary, highlights, and chapter. And I'm gonna click generate, and it's currently generating, the titles, the topics, hashtag, the summary. Yep, and also like these highlights, right? So the highlights are the key moments happening in the video that our model was able to automatically detect. And then chapters, so we basically break down the video into multiple chapters. So you can see here, it looks like in the first 15 seconds, there's a group of women walking, dancing, singing various location. And then for the next 15 seconds, right, the video captures the scenes where people enjoy themselves. And if you click into this chapter, yeah, so it takes you directly to that part, and then you can easily like know what's going on, like what's happening in that chapter, right? And then finally, there's an option here called Build My Own. So think about just like how you prompt different large language model, to generate the text based on the very special style. You can achieve the same thing here. You can prompt our Pegasus model to create an output that is like based on very specific style. So for instance, here I'm just gonna say, this describe this video, a comedic tone. Yeah, so it pick up that tone and just return your output in a very like comedic element. And maybe something like write a short poem based on this video. Yeah, so you can see it generates like the poem format, right, based on the content of the video. Perfect. Let me go back into the presentation. And we actually recently did a tutorial with the 51 teams. We're working with Daniel Hura, who's one of the ML evangelists at 51 to construct this tutorial. I would highly recommend you checking it out, where he built like a 51 plugin. Sorry, when he built 51 plugins to deal on the on the GitHub repo, where you could perform semantic video search directly, within the 51 environment. So highly recommend you checking out this blog post that I collaborated with him to work on it, that explained the end-to-end process. And then in my final slide, just quick note on, if you're interested in trying out a solution, you can go to playground.toylabs.io. And also, I'm also very big into sort of community building, just like how, Fox has been building with computer vision. And I've been managing a Discord community called Multimodal Minds, where there's a lot of practitioners and researchers discuss some of the latest papers or open source project application in multimodal AI. So if you're interested in, dive into this exciting new world of AI, you can, just scan this QR code and join our Discord. So yeah, that's the end of my talk, and appreciate, your attention, and thanks Voxel for the opportunity to showcase some of our work with Toy Labs.
Awesome. Thank you, James. So there doesn't appear to be any questions in the Q&A widget, but I did include a link to James' LinkedIn profile there in the webinar chat. So if you want to get connected over to him over on LinkedIn to start a conversation about the work that he's doing over at 12 Labs, or to join the community that he's building, that's probably a good, efficient channel to get connected. So thank you, James. Maybe there is time for one quick question here. The question is, can you describe a few commercial applications in which 12 Labs can be used?
Yeah, for sure. So the really cool thing about building a foundation models for video is that it can generalize to a variety of domains, right? So we've seen a lot of use cases in sports. So you think about football or soccer or basketball, right? Like they have a lot of footage in previous seasons that they want to monetize or upsell to advertisers. So they've been using our solution to find this very high value video footage, so that they can like upsell that to advertisers. Sometimes, in specific teams, footage of players trading, right? The coach want to rewatch certain plays from past season, and want to coach the players to perform better. So using our solution, they can capture those the details and therefore enhance a lot of the performance of players. Another one that I think was also very relevant is media and entertainment. So if you think about the process of making TV shows or movies or trailers, right? Usually to shoot like a 30-second commercial, I imagine, and actually, talk a lot of like broadcaster and editors in this space, you probably have to shoot like 20 hours footage just to cut down to that 30 seconds commercial. And in order to like edit that 20 hours footage, you have like traditionally you have to manually ship through the whole 20 hours and like find that exact moment. But using our search solution, you can quickly find that clip just by typing the query and then quickly identify that part and then edit your final product together. So yeah, that helps decrease the time it takes for video editing and accelerate the asset that you can generate.